Okay, good morning everyone. Welcome to another lesson. Today's lesson is going to be on double angle formulas. So you can either print out the note guide or just write this down on a piece of paper. Okay, so things that we will be needing today. So the first thing is, here's our unit circle. And let's just review our quadrants. So we have quadrant 1, 2, 3, and 4. Also today we're going to be going back to right triangle trig. So if you take a look at this diagram over here, here is our right triangle. Our inside angle here is called theta. So this side would be the adjacent side. The side across from theta would be the opposite side. And then we have the side across from the 90 degree, which is our hypotenuse. So going back to right triangle trig, at the beginning of the year, we had SOHCAHTOA to help us define the three trig ratios. So the ratio for sine was opposite over hypotenuse. So if this is theta, opposite I'm going to call y, hypotenuse I'm going to call r. So sine would be y over r if we were to put this in the coordinate plane, which we'll be doing in a minute. Cosine. Cosine is adjacent over hypotenuse, so cosine would be adjacent, which is x, over hypotenuse, which is r. And then lastly, tangent. Tangent is opposite over adjacent, so that would be opposite is y, adjacent is x. Okay. Going back to what we learned last week. Last week we talked about angle addition. So that was saying something like, if you were finding cosine of 75, 75 is a degree that is not on the unit circle. So what you would do is we would take two values that are on the unit circle, like 45 and 30, and we would find the value of each of those. It's not just as easy as adding 45 and 30. We derived the formula that this was the angle addition formula for sine. We do all this crazy stuff, and this was the angle addition formula for cosine. So today we're going to take this a little bit further, and today we're going to talk about something called a double angle formula. So what happens if, instead of finding cosine of 75, what happens if I want you to find, say, cosine of 60? Okay? 60 does happen to be on the unit circle, but let's just say it wasn't. And we know that 60 degrees is 30 plus 30. So today we're going to talk about, this is called a double angle because these two smaller angles end up being the same. Whereas last week when we found the bigger angle, we added two smaller angles that were different. Today we're going to talk about what happens when these two smaller angles are the same. So the first thing I'm going to do is take you through how we find these formulas, and then we'll do some work with them. Okay, so we're going to start with deriving the double angle formula. Okay, so let's start. So let's start first with sine. Okay, so say I'm going to find sine of 60, and we're saying that sine of 60, the two smaller angles would be 30 plus 30. And these two smaller angles are the same, so I'm going to actually call that sine of x plus x. I'm just going to change these 30s to x's. It could represent anything. 45 plus 45, 50 plus 50. Any two angles that are the same. Okay, and now what we're going to do is just plug into the angle addition formula for sine that we learned last week. So, sine of A, cosine B. Well, our two angles this week happen to be the same. So we would do sine of x, cosine x, plus this angle addition from last week, cosine A, sine B. But again, this week, our two angles are the same. So it would be cosine x, sine x. Okay, so let's take a look and see what this is. So sine x, cosine x is the same as cosine x, sine x. This is like saying 2 times 3, that's actually the same as 3 times 2. You get the same answer, 6, you're just looking at it differently. So we can actually write this second one as sine x times cosine x. Same thing, just in a different order. So this is 1 sine x cosine x plus 1 sine x cosine x. So our final answer would be 2 sine x cosine x. So this is our first double angle formula that we will be using for sine. So now let's derive the formula for cosine. No, we'll stay here. Okay, so let's derive the double angle for cosine. Okay, so same thing. Now we're going to do cosine of 60. Cosine of 60, we're going to say is 30 plus 30. So we're using two of the same angles. So I'm going to derive for you cosine of x plus x. So we're going to just plug into the same formulas up above. Last week, the formula for angle addition for cosine was derived, a plus b, two different angles. This week we're going to use these two angles the same. So we'll start. It will be cosine of x times cosine of x. Then it will be minus sine of x times sine of x. Okay, so let's just simplify that. Cosine times cosine. So cosine times cosine is cosine squared. That's the same as x times x is x squared. So this is cosine squared x minus sine times sine is sine squared x. So this is the formula, the double angle formula for cosine. So now for cosine, there's easier ways that you can look at this. So I'll just show you the two different ways that will simplify this. So let's start first by substituting in for cosine x. So if we want this whole thing to be in terms of sine, if we go back to Pythagorean identities, which I have the Pythagorean identities right here. Okay, so these are the Pythagorean identities. We can substitute in for cosine x right here. I'm going to substitute in 1 minus sine squared x. So this is going to be 1 minus sine squared x, and then I'm going to continue with minus sine squared x. Now we just simplify. So a negative sine squared and a negative sine squared combines to negative 2 sine squared. So another way we can look at this formula is 1 minus 2 sine squared x. Okay, and now we're just going to look at it in lastly one other way. So now we're going to substitute in for the sine squared x. So keep cosine squared x minus, now let's substitute in for sine squared x. So we go back up here to our Pythagorean identities. So sine squared x, we can substitute in 1 minus cosine squared x. Okay, distribute this negative. So we have cosine squared x minus 1 plus cosine squared x. So this whole thing will simplify to, so a 1 cosine x plus a 1 cosine x, or sorry, 1 cosine squared x plus 1 cosine squared x is 2 cosine squared x, and then minus 1. So this part right here is just deriving the formulas. Now we're going to put the formulas to use. So if you're with me on that, good. If I lost you a little bit, that's okay. The main part is next we're going to use these formulas. But instead of just, throwing formulas at you and say use these, I want to actually show you where they come from. All right, so let's do a couple example problems now. Okay, so here are the formulas that I just talked about. So your double angle sine formula, you only have one, would be 2 sine x cosine x. And then if they're asking you to find cosine, you have a couple different options here. Okay, these are the steps that we'll be using. The first thing we need to do is figure out what quadrant that we'll be working in. Second, we might have to find parts of a right triangle. We might have to find the radius of a right triangle, depending if they want us to find sine, cosine, or tangent. So that's number 3. And then number 4, we will determine which double angle formula we will be plugging into and solving. Okay, so we'll be going back up to there. So let's start with number 1. So number 1, tangent is 12 over 5, and where 0 is less than equal to theta, less than equal to pi over 2. Okay, so these are our restrictions. So this is going to tell us what quadrant are we looking in. What quadrant are we looking in? So the first thing, let's figure that out. So that's step number 1. Use the restrictions to determine what quadrant you're working in. So this says between 0 and pi over 2. So go back to your unit circle. Here's 0, here's pi over 2. So we're working in quadrant 1. So if we're working in quadrant 1, let's go ahead and draw a right triangle in quadrant 1. So we're going to put the information given to us on that triangle. So we are given tangent, 12 over 5. If you need to, go back. Tangent is y over x. So in this case, your y would be 12. Your x would be 5. So now, before we do any work to do the Pythagorean theorem, let's see if we need it. So we are finding sine of 2 theta. So if we're finding sine of 2 theta, or double angle of sine, we need to have the sine ratio and the cosine ratio. So right now we only have the tangent ratio, so we will have to do Pythagorean theorem. Oh, sorry, this should have been a 5. Okay, so some of you might know this as a Pythagorean triple. If you don't recognize this as a Pythagorean triple, we're going to have to do the Pythagorean theorem to find the hypotenuse. So over to the side, we would do 5 squared plus 12 squared equals, you could call it c squared, h squared, r squared, whatever you want. 25 plus 144, 169. So we're taking the square root of 169, so 13. Okay, all of these values are positive because we're in the first quadrant. All right, so now we have all the information that we need. We're finding sine of 2 theta. So this is the formula that we're using. So 2 sine of x cosine of x. I'll just write that here. So now we just plug in. So 2 stays. Sine of x, we're now putting the sine ratio in. So sine is opposite over hypotenuse. So 12 over 13. You could always go back to that first sheet if you need to. Here are your ratios if you need them. Okay, and now we're putting in the ratio for cosine. So cosine is x over r, or cosine would be adjacent over hypotenuse. Now all we do is this math. This is actually 2 over 1. So numerator, 2 times 12 times 5. Denominator, 1 times 13 times 13. So the top, 2 times 12 times 5 is 120. The bottom, 169. And we can just leave it. We don't even have to reduce it. Okay, let's try a couple more together. All right, number 2. So using those steps again. So step number 1, use the restrictions to determine what quadrant are you working in. Here are our restrictions over here. So between pi and 3 pi over 2. So take a look at your unit circle and figure out pi and 3 pi over 2. What quadrant is that? Okay, so that's quadrant 3. So we're drawing our right triangle in quadrant 3. So your right triangle is always going to go up to the x-axis, and theta is always going to be on the inside. Okay, information that's given to us now. So this is step number 2, create a possible right triangle in the coordinate plane. Okay, did that. Number 3, use the Pythagorean theorem to find the other ratios if needed. Okay, so first let's see if we have to do it. So we have cosine, negative 3 over 5. So we know cosine is x over r. So you need to figure out which one would be negative here. So this is the negative, negative 3, because we're going in the negative direction on the x, the hypotenuse is always going to be positive. Okay. So if we're finding sine, so double angle of sine wants you to have a sine ratio and a cosine ratio. So right now we have a cosine ratio, but we do not have a sine ratio. So we will have to do Pythagorean theorem to find that. So you might just know this. This is the most famous Pythagorean triple, a 3, 4, 5. If not, you could do the Pythagorean theorem, but you just have to put the appropriate positive and negative signs. So if this is negative 3, this y right here would be negative 4. Okay, now we have enough information. Our right triangle is complete. We have enough information to put in our sine ratio and our cosine ratio. So let's start. 2 times sine. Sine is opposite, and you can always write that SOHCAHTOA up there if you need to. So sine is opposite over hypotenuse, so negative 4 over 5. Cosine was given to us in the beginning of the problem, negative 3 over 5, but if you want to, you can always again look at the triangle. Okay, now multiply straight across the top, straight across the bottom. So the top, 2 times negative 4 times negative 3 will give you 24. The bottom, 5 times 5, 25. Okay, so once you get used to it, it becomes a little bit easier. It's just knowing, what ratios you need. All right, let's finish up with the last 2 problems, and then you only have a small amount of practice problems this week. So let's do number 3 together. It's working with the double angle of cosine, so cosine double angle, so we're going to use a different formula this time. Then I'll have you try 4 on your own. Okay, so same thing, start it the same way. Start with your step number 1. Use your restrictions to determine what quadrant are you in. So here are your restrictions. Restrictions say pi and 3 pi over 2. Okay, so here's pi. Here's 3 pi over 2. We're in quadrant 3. So next step, go ahead, draw a triangle in quadrant 3. Your triangles always go up to the x-axis. Theta always goes on the inside. Let's go ahead, fill that right triangle in. So sine is negative 4 over 5. We know sine is opposite over hypotenuse. So opposite, this would be the negative 4. So if you're in this quadrant, you have to remember there are negatives in quadrant 3 here. So you have to put the negative with the appropriate side. And then the hypotenuse is 5. So what I would say here, especially when you're working with cosine double angles, before you do any work and use the Pythagorean theorem, most of the time you will not have to. So let's take a look and see. So our cosine double angle formula. So cosine double angle formula, you have 3 options that you can use. So we know that our problem gave us a sine ratio to begin. So it just seems that the easiest one to use here would be this third one. I actually don't have to do any Pythagorean theorem. All I have to do is 1 minus 2. I'm going to put my sine ratio in there, and I'm just going to square it. Okay? So for cosine ones, go straight to the formulas, okay? And most of the time you won't have to do Pythagorean theorem. So that's the one I'm going to use for cosine. 1 minus 2 sine squared x. All right, so let's plug in. So 1 minus 2 times. My sine ratio is negative 4 over 5. It's being squared. So now we just have to do order of operations. We have to square the fraction first, multiply it by 2, and then we'll do 1 minus that. So this fraction squared is 16 over 25. So we have 1 minus 2 times. Order of operations says we need to do this first. So it's 1 minus 32 over 25. And then when you get here, you can either use your calculators to do 1 minus 32 over 25, or you can change 1 to a fraction, which would be 25 over 25 minus 32 over 25. So your final answer to this one is negative 7 over 25. Okay, at this point, you might want to pause the video, try number 4 on your own. It's a cosine double angle. So definitely do step number 1 to figure out what quadrant you're working in. You might not have to do 2 and 3, so go straight to the formulas and see. Okay, try number 4 on your own, then unpause the video, and we'll go over this last example. Okay, so number 4. First thing, we start with the restrictions. Let's figure out what quadrant we're working in. So pi over 2 and pi. So pi over 2 is up here, pi is right here, so we'll be working in quadrant 2. So your triangle would be here, and sine is opposite over hypotenuse. Okay, but you actually don't really even need to do that, because if we're finding cosine, double angle of cosine, we come right up to here, double angle of cosine, we need to figure out which one should we use. Well, the problem gave us the sine ratio. It gave us a sine ratio of 1 over 7. So I'm going to just go straight to here and plug in. So I'm plugging in to 1 minus 2 sine squared x. 1 minus 2, in for sine, I'm plugging 1 over 7, and it just has to be squared. Square it first. So 1 minus 2 times, this would be 1 squared is 1, 7 squared is 49. So now we do this order of operation, 2 times 1 over 49. So this would go to 1 minus 2 over 49. And at this point, you can either use your calculators or you can change 1 to a fraction with a common denominator. So it would be 49 over 49 minus 2 over 49. Final answer, 47 over 49. Okay, I'm going to probably give you maybe 6 practice problems. Try your best, even if you can't get to the complete 4 steps of this. If you can at least get to step 1, figure out what quadrant you're working in. Step number 2, create a right triangle, do the Pythagorean theorem if needed. Okay, so get as far as you can on that, and I'll be posting answers. Thanks. Have a good week.